So welcome you guys to the second session of exploratory data analysis using this IDS dataset. So I first want to tell you one thing. I'm going to change the name of this file day1 because in single file I will keep on here. I will keep on putting day1, day2, day3 because I will be using the previous things also. To that's why this will be a better idea. Fine. So let's first change the name. So I'm just renaming it and let's put X exploratory underscore data underscore analysis. This is the name of my file. Exploratory data analysis. Fine. So I've changed the name. Let's save the changes. Now what I'm going to do here in this file, these are some things we have discussed earlier, I suppose. So I have written day1 here so that you can understand what we had discussed in the day1. And let's put this is day2. That means the day2 starts here. So whatever we are going to discuss, likewise, I will keep on putting day here only. So this is clear. Now let's understand what we are going to study today. Today, last thing that we have discussed here, this was a balanced data set because everything, Setosa is having 50, Versicolor is having 50, and Virginica is having 50. Equal number of value counts these are having. So today we will first try to understand the imbalanced data set with few examples. So let's take the first example. Let's first take the example. Let's say, imagine if you are a data scientist who is working at a hospital. And let's assume that the hospital is having 10,000 patients. This hospital is, let me open you my notebook. So let's suppose this hospital is having 10K patients. Fine. And for each patients, we have many fields. That is, we have many features. Let's say F1 is one feature, F2 is another feature, F3 is another feature, and F4 is another feature. Likewise, we have so many features. Let's say we have 10 features. F1 till F10. For each patient, I am talking about each patient. So what it means, each of these fields means each of these features could be the results of some medical tests or some medical examination or maybe a doctor's prescription. So it could be a lot of features. So, but let's assume we have 10 features of each of the patients. So let's assume we have 10 features of each of the patients, F1 till F10. So my, let's say my data matrix will look like this. Let's say my data matrix will look like something like this. This is, let's say, my data matrix. And here is my features of every patient. And here is a level. Fine. So for each patients, we have a response level or class level. This is my response level or a class level. This is called response level or class level, which shows whether the patient has diabetes or not. I want to find whether my patient, this patient has diabetes or not. Let me write this. Whether the patient has diabetes or not. Fine. This is my response level. But we know this thing that out of, let's say, 10,000 patients which goes to the hospital for some kind of treatment, only a very small number of patients is diabetic. So let's assume out of this 10,000 patients which visits the hospital, 500 patients are diabetic. 500 patients are diabetic. So how many non-diabetic patients are there? 9,500. That means 9,500 patients are non-diabetic. This we know from our experience that only small percentage of the people or patients or a small number of the patients which visits the hospital is diabetic. So now our task is given this 10 features given. So I have given these 10 features F1 till F10 and which corresponds to some medical test. These features is basically what? This is let's say these features corresponds to some medical tests. Let's say if a patient is admitted or went to the hospital, he went through certain medical tests or certain examinations, and out of that medical test examinations, these values are coming F1, F2, F3. So these are basically the features which corresponds to some medical tests. Now we have to predict whether the patient has diabetes or not. We have to predict, and this is my prediction thing. Considering these features, I have to predict whether the patient is diabetic or not. So the above thing, the above data set that we are seeing right now is imbalanced because we have two class levels here. My first class level is diabetic and the second class level is non-diabetic. And the number of data points in each class is very different. One class is having 500 data points and other class is having 9,500 data points. So data points in each class is very, very different. That's why this type of data set is called imbalanced data set, where one type of data is very high in number than the other type of data. If you can compare here, this data, diabetic patient data, is very less, very, very less in comparison to the non-diabetic patient data. So this type of data set is called imbalanced data. Let's see if the diabetic patient number will be kind of, if 4,000 will be the diabetic, and let's say out of this 10,000, 6,000 patients will be non-diabetic. Then what happened? Would you call it imbalanced data set or balanced data set? In my opinion, I would call it almost balanced, as it is not as severely imbalanced as this data. This 500 and 9,500. This is also imbalanced, but it is not severely imbalanced. So this is okay. This is kind of okay. The reason we are discussing this imbalanced data set is because when we have imbalanced data set, we have to do slightly different, not significantly different, but slightly different data analysis as compared to the balanced data set. So that's why I am discussing this imbalanced data set and a balanced data set. Now let me give you one more example to understand the same thing, imbalanced data set. So you must be heard about. So imbalanced data set is like, let me, if I will write it here, imbalanced data set is like Let me write the imbalanced dataset definition here. An imbalanced data set is one where the where the distribution of the classes is not uniform, meaning that one or more classes have significantly fewer samples samples than the compared to the others. Compare samples compared to the others. Fine. Now, imbalanced dataset is one where the distribution of the classes is not uniform, meaning that one or more classes have significantly fewer samples compared to the others. Let me give you one more example. Suppose you are working on a credit card fraud detection task. The vast majority of the credit card transactions are legitimate. That is, they are legal. But that is non-fraudulent transactions I am talking about. But a very small percentage might be fraudulent. Let's say, let me give you one example here. Let's say 99.9% transactions are non-fraudulent. Fraudulent. Fraudulent. And only 0.1% transactions are fraudulent. DULENT. Fine. In this case, can you see? I'm talking about the credit card fraud detection, in which 99.9% transactions are non-fraudulent, but only 0.1% transactions are fraudulent. In this case, also we have an imbalanced data set where this fraudulent class, this fraudulent transactions is heavily outnumbered by these non-fraudulent transactions. This is very, very high number comparison to this. So this is also an example of, let's say, this imbalanced data set. Fine. This is all about the balanced data set and imbalanced data set. Next thing that we are going to discuss is the 2D scatter plot. So that's fine.